At the end of this chapter, you'll be able to identify and locate the components of the fire protection system. Describe the layout of the fire protection system and identify its subsystems and interface. Explain the operation of the fire protection system main components. Identify and explain the controls associated with the fire protection system. Identify and explain the indications and enunciators associated with the fire protection system. The fire protection system is designed to reduce the chances of an eventual fire in the engines and on board the aircraft by detecting fire or smoke at the earliest possible time, and by clearly indicating the source of the fire to the flight and cabin crew. The purpose of the various protection systems is to detect and extinguish the fire on an engine, detect smoke from the air conditioning system, the avionics compartment, the cargo compartments and lavatory, and automatically detect and extinguish the fire in the lavatory dustbin. Engine fire detection is achieved by thermosensing loops, which trigger the respective engine fire warning if an overheat situation is detected in the monitored area. The engine fire detection system is comprised of two identical and independent loops mounted in parallel on each engine. They are called Loop A and Loop B. The fire detection principle is based on the variation of the resistance and capacitance of the detection wire. If only a change in the wire resistance is detected by the system, the fire detection control unit considers the respective loop as failed. The engine fire extinguishing is achieved by two Freon or Halon fire extinguisher bottles located one on each side of the fuselage at the junction of the fuselage and the wing. They can be both used for engine number 1 or engine number 2. And each bottle is fitted with two squibs that release the extinguishing agent to the respective engine. For the left engine, Agent 1 refers to the bottle located on the left side of the fuselage, while Agent 2 refers to the bottle located on the right side of the fuselage. For the right engine, Agent 1 refers to the bottle located on the right side of the fuselage, while Agent 2 refers to the one located on the left. The right-hand engine is equipped with a Nacelle overheat detection system. If an overheat condition is detected by the sensor located below the right-hand engine gas exhaust area, the red Nacelle overheat light on the CAP is illuminated and the CCAS is activated. Note, this function is available on ground only. In this case, the respective Nacelle overheat checklist found in the QRH chapter Procedures Following Failures must be applied. Smoke detection for the avionics compartment, cargo compartment, and lavatory is achieved by smoke detectors which trigger the respective smoke warning. The avionics smoke detector, located in the avionics extract air duct, is linked to the CCAS and will trigger the appropriate warnings if smoke is detected between the avionics compartment and the extract fan. Note that the aircraft is not fitted with a dedicated smoke detector for the air conditioning system. Instead, the avionics smoke detector will sense any smoke coming from the air conditioning system because of the ventilation system design. Observe that in both situations only the indication of electrical smoke is available. The forward cargo compartment and the rear cargo compartment are each fitted with one optical smoke detector, and the lavatory is equipped with one photoelectric smoke detector. If any smoke is detected in the cargo compartments or in the lavatory, the MFC activates the CCAS and a warning will be generated to the flight and cabin crew. A fixed fire extinguisher bottle located in the lavatory dust bin will automatically extinguish any fire breaking out in the lavatory dustbin. When a heat source produces a temperature of approximately 80 degrees Celsius, the ends of the tubes melt, and an agent is discharged into the dustbin. The ATR is also fitted with portable fire extinguishers. They are located in the cockpit and in the passenger cabin area to enable crew intervention in case of fire on board. If a fire in the rear cargo compartment occurs, the cabin crew can fight the fire by connecting the portable fire extinguisher on the appropriate connector, located on the aircraft rear wall near the flight attendant panel, and discharging it. The extinguishing agent will be spread into the rear cargo compartment via diffusers installed in the respective compartment. To learn about the electrical supply, take a look at the table. It shows the equipment related to fire protection and the associated power supply. For control of engine fire detection and extinguishing, two identical engine fire panels, one for each engine, are located on the cockpit overhead panel. Each of them comprises the following features: a fire handle with an integrated red fire warning light, a Squib Test push button, two agent push buttons, Agent 1 and Agent 2, two loop push buttons, Loop A and Loop B, a test switch that is spring-loaded to the neutral position. The fire handle in its normal pushed-in position is locked by a latch and secured by a lock wire. Before pulling the engine fire handle, it is necessary to lift the latch and break the lock wire. Once the fire handle is pulled, it will electrically cause, for the respective engine, the feathering of the propeller, the closure of the engine fuel low pressure valve, the closure of the engine bleed valve and the high pressure valve, the closure of the de-ice valve and the isolation valve, the deactivation of the DC and AC wild generators, and the illumination of the on-side squib lights. The Squib Test push button is responsible for testing the squibs located in the discharge heads of the fire extinguisher bottles and their respective electrical circuits. To perform the test, press the push button and observe both squib lights in Agent 1 and Agent 2 push buttons illuminating white. This indicates that the test was successful and the system is operational. Now you can release the Squib Test push button. Note that the test can only be performed if the respective fire handle is in its normal position. The normal position for the Agent 1 and Agent 2 push buttons is released. The push buttons are fitted with a white squib light that will illuminate as soon as the respective fire handle is pulled, in order to facilitate the identification of the agent push buttons. And when depressed, they command the squib's ignition and by consequence the discharge of the fire extinguisher bottles. They are also fitted with an amber DISCH light to indicate that their respective fire extinguisher bottle is depressurized The loop push button's normal position is depressed, and once one is released, the respective loop is switched off. If the loop push button is on, both aural and visual alerts are active in case the respective fire detection control unit generates an engine fire or a loop fault signal. If the loop push button is selected to off, the alerts are inhibited for the related loop. The white off light in the push button illuminates, and the CCAS is activated, generating a single chime, the master caution flashing light, and the amber loop light on the CAP. A loop fault can be detected by the system only if the respective loop is on. In case of a loop fault, the CCAS is also activated, and the flight crew will be informed about the situation by a single chime, the master caution flashing light, the amber loop light on the CAP, and by the amber fault light in the respective loop push button. Note that if one loop fails, it must be selected to off. Otherwise, the remaining loop will not activate the fire protection system. The test switch allows the engine fire detection and loop fault signals to be tested only when both loop push buttons are selected to on. When the switch is held to fault, both loop A and B amber fault lights illuminate in the related loop push buttons. The CCAS is activated, and the amber loop light on the CAP comes on. If the switch is held to the fire position, the respective engine fire handle illuminates red. The respective condition lever fuel light illuminates red. The CCAS is activated, generating the master warning flashing and the continuous repetitive chime, and the respective red engine fire light illuminates on the CAP. On top of each condition lever, there's a red fuel shutoff light. This light illuminates in case a fire on the associated engine is detected by the system and if the condition lever is not in the fuel shutoff position. The light will automatically extinguish as soon as the condition lever is placed to the fuel shutoff position or if the fire detection signal is terminated. On the overhead panel, you'll see the cargo compartment and toilet smoke detection panel. A smoke test push button is located on this panel to test the function of the smoke detectors. When the push button is depressed and held, the CCAS is activated, generating the master warning flashing light, the continuous repetitive chime, and the illumination of the aft smoke, forward smoke, and electric smoke red lights on the CAP. This panel is also fitted with the aft compartments and lavatory push button. Its normal depressed position allows a fan to pull and duct the air from the toilet to the toilet smoke detector. In case the fan fails, an amber fault light illuminates in the push button, activating the CCAS, generating the master caution flashing light, a single chime, and the amber air light on the CAP. If this occurs, follow the failures checklist, after compartments, lavatory detection fan fault, from the QRH. Let's now simulate an in-flight engine fire on the left engine. At the moment a fire condition is detected, the Engine 1 fire handle illuminates. The respective condition lever fuel light illuminates red and the CCAS is activated. The correct procedures in case of an in-flight engine fire are described in the QRH chapter Emergency Procedures, In-Flight Engine Fire or Severe Mechanical Damage. Observe that the boxed items must be done by memory. In the previous lessons, we learned about the alerts in detail. This list provides you with an overview of all alerts and their related indications.